All right. We want to talk about partial differentiation. So in our previous videos, we've done tutorials on differentiation. You know what differentiation is? To differentiate a number, or to differentiate means to express a particular function with respect to f. That's a change in y, right, over change in x, right? That is for differentiation. From differentiating, it's always with respect to x. Then now when we talk about implicit differentiation as well, we said that implicit differentiation has to do as well with respect towards x. So you are differentiating in implicit differentiation with respect towards x. So now, what about partial differentiation? In partial differentiation, the case is different, mainly because of one thing, and that one thing is that you are not differentiating with respect to x, right? You don't differentiate just with respect to x. You differentiate with respect to what you are given. For instance, if I have let's say z to be a function having 3x squared y raised to power 4 minus 5x raised to power 7 plus 4y raised to power 8. Now you see that you have x and you also have y. Just like is always the case in implicit differentiation. Now if I'm to differentiate this implicitly, what I'm going to do basically is to differentiate everything here with respect to what? With respect to x, right? That means if I have this 3x squared y raised to power 4, I'll count x squared as u and then v, and then y raised to power 4 as what? V. Same thing I always do, that's product of two products, right? That's products function, right? So what are you going to do now? Remember, in product, you take the first one, that's 3x squared, right? Then differentiate the second one. If I differentiate y raised to power 4, I'm going to get this 4 comes down. You have 4y raised to power 3. But whenever I differentiate a variable that is not x, you always ask what? Dy dx. So blocks, right? Because basically what you're doing is what? Implicit differentiation. Blocks. Take the second one, which is y raised to power 4. Then differentiate 3x squared. You're going to have, so you have 3 already. You're not affected. So you have 2x, right? 2 minus 1, you would 1. So just have 2x minus 5x raised to power 7. 7 comes down. Gonna have 35 x raised to power what? 6. That's 7 minus 1 is 6. Then you differentiate this 4y raised to power 8 as well. For differentiate 4y raised to power 8, I'm going to get 8 comes down. That is 8 times 4. That will give you 32. Y raised to power what? 7. Right? So, but you're going to add what? Dy dx to it as well. So what are we going to do now? At this point now, you take all the ones that are having dy dx to one side, take the other ones to the other side. So I'm going to have 3x squared 4y raised to power 3 dy dx plus 32, right? Y raised to power 7 dy dx plus 3y raised to power 4. Sorry, so 3 times 2 is what? 6. 6y raised to power 4 x, right? Then you have minus 35 x raised to power 6. So what you're going to do basically now is to move these guys that have dy dx over to the other side of the equation. So I'm going to have 3x squared 4y cubed dy dx. Remember, there will be a minus sign. Plus, c minus 32 y raised to power 7 dy dx is equal to, right? So remember, these other two guys now move over to the other side. So these other guys will remain the same way they are. 6y raised to the power 4x minus 35x raised to the power what, 6. So what are we going to do now? So I'll take out this dy dx. So if I take out dy dx, what will remain here is minus 3x squared. Sorry, 3 times 4 is what, 12. So there's no point doing it that way. 12x squared y raised to the power what, 3, right? And then minus as well, 32 y raised to the power 7 equal to 6y raised to the power 4x minus, you have 35x raised to the power 6. So now you're going to remove this guy from both sides. That means dy dx will be equal to, divided by this, you have 6y raised to the power 4x minus 35x raised to the power 6 divided by minus 12x squared y raised to the power 3 minus 32 y raised to the power 7. So that becomes what? Your answer if you differentiate implicitly, right? That's for implicit differentiation. Now, if I'm to differentiate this partially, now you take note. If I'm to differentiate this partially, it means this z equal to 3x squared y raised to the power 4 minus 5x raised to the power 7 plus 4y raised to the power 8. That means I'll first of all differentiate this z with respect to x first. If I differentiate with respect to x, it means anything that is not x will be a constant, right? Anything not x becomes what? A constant. So what I'm going to have now is x 3x squared, right? I'm going to differentiate this guy. So I'm going to have 6x squared, which is a constant. It remains the same, right? Y raised to the power 4. Then here is minus 5x raised to the power 7. 7 comes down, right? You have 35x. So now, if you differentiate a constant here, remember, this is not a variable in x, but we are differentiating with respect to x. That is the partial derivative, right? So if I take this as a constant, same way, whenever you differentiate a constant, you get what? 0. So the same thing is going to happen here. If I differentiate this now, 4y raised to the power 8, I'm going to get what? 0. Because I'm taking it as a constant, right? I'm going to have 6x squared y raised to the power 4 minus 35x. That's with respect partial derivative of this with respect to x. Now take also the partial derivative of that function with respect to what? Y. Now with respect to y, I'll take any x variable I see as what? A constant. That means your 3x squared becomes what? A constant. I'm going to have 3x squared, then 4y. I'll differentiate it. I'll have 4y raised to the power 3. Then minus, this is a variable in x. 5x raised to the power 7 is a variable in x and not y. So it's going to be 0 plus 4y raised to the power 8. I'm going to have 8 times 4 give you what? 32. So you have 32 y raised to the power what? 7. So gives me that you have 3x squared. Sorry, 3 times 4 is what? 12. You have 12x squared y raised to the power 3 plus what? 32 y raised to the power what? 7. Now, the total partial derivative now, total partial derivative, what are we going to have it as? So you're going to actually have it as this. There's actually a formula that I'll just put out for you to identify it. So if I take the partial derivative of the variable this with respect to what? X and y, so it simply means that I'm going to take that the partial derivative of this with respect to what? X plus partial derivative with respect to what? Y. That means I'm going to add the two together. So the partial derivative with respect to x plus the partial derivative with respect to what? Y. If I add them together, I'm going to get total partial derivative of it. So it means I'm going to have 6x squared raised to the power 4 minus 35x plus 12x squared y cube plus 32 y raised to the power 7. So that becomes our answer. So that's basically how we compute partial derivative of a particular function. Okay, so one more exercise and then we call it a wrap. We have something like this. We have a function f x comma y, right? Xy squared plus y x raised to the power 3. So we say the first thing is what? To differentiate f with respect to what? X. Partial derivative with respect to x. That means I'm going to be differentiating x, guys. If I differentiate x here, remember this is sx y squared. So y squared is the constant. So constant remains the way they are. So plus this guy now. So you're differentiating with respect to x. That means you're going to differentiate this x variable, not the y. So you have 3x squared y. So that becomes the partial derivative with respect to x. So you take the partial derivative with respect to y. You're going to have, that means you're differentiating this y guy. You have 2y, right? X, 2yx plus differentiate this y guy is 1, right? So you have just x is to the power 3 times 1, which is what? X is to the power 3. So this is going to be your